Section 2.1 is all about functions. We'll start by talking about what the definition of a function is. We will look at some examples to try and decide if they are functions or not, both graphically and by looking at ordered pairs and tables. And then after we've explored whether something's a function or not, we'll look at domain and range and trying to decide what that looks like, as well as function notation. The definition of a function is that it's a rule that takes each element in the domain and it assigns it to exactly one element in the range. Another way to say this is that it's a set of ordered pairs where no two ordered pairs have the same first coordinate but different second coordinates. We typically call the first coordinate the independent variable. This is referring to the x value. The second coordinate is called the dependent variable. Any set of ordered pairs that we can have where we have an independent variable, comma, the dependent variable, is called a relation. So in this case, all functions are relations, but not every relation is a function. Again, a set of ordered pairs is called a relation. Now that we've explored some of the terminology, let's start deciding if something's a function or not. So if we want to graphically decide if we have a function, we can use this thing called the vertical line test, which I'll explain in just a minute. So if we have some graphs and we want to decide if we have a function or not, we need to use this thing called the vertical line test. And the idea is that a vertical line, with the vertical line test, if we put a vertical line, remember those go up to down. If we put a vertical line anywhere on the graph, that it will pass through the graph only once. If there is one vertical line that passed through the graph in more than one spot, then it's not a function. Okay, it could be, and usually when we have non-functions, there'll be multiple places where the vertical line test fails, but it only needs to fail once. So I thought we would play this little game to try and decide if we have a function or not. And I'm not going to use the most accurate graphs ever, but we'll start with this graph. It's supposed to be a circle. Okay, so again, if we use the vertical line test, I could use a laser pointer, but I'm going to draw in some lines. Alright, so here we go with some lines. I'm going to draw these in red. You don't actually have to draw them in every time, but the idea is if we were to start placing some lines. Why is this not working? Notice if we were to draw a vertical line, we could draw vertical lines over to the left of the graph. That's fine. Then it might touch one place. And then as we move closer, we can see that these vertical lines are passing through more than one point. Okay, the idea here is that we only had to have one line that fails, but as we draw vertical lines, notice that we've got vertical lines that are passing through 2 points. And even though I could draw it so it maybe only cross through 1 point, it doesn't matter. So the idea is this one is not a function. It fails the vertical line test because we have at least one vertical line that is going through the graph in more than one spot. Okay, if we look at this graph, this one's going to look like a curvy W. How do we decide if this one's a function? And one thing that I will say, because this tends to add a little bit of confusion, is these pieces I'm erasing. I'm going to be a little more dramatic. The idea is that these are extending in either direction forever, but they are not vertical. Sometimes that confuses people. Okay, here's your x-axis, here's your y-axis. Don't mind a couple of my straight lines. How do we decide if this is a function? Well, we can do exactly the same thing we did before. We can think about starting to place some vertical lines. Notice every vertical line we've placed, and you don't actually have to draw these in. I like to actually turn my pencil sideways and think about moving it along the graphs. But do you guys see that for every place it only hit the graph in one spot, which would make this one a function. And you might be thinking, okay, those don't seem so bad. So let's look at one that looks a little bit different. We're going to look at a piecewise function. In order to draw a piecewise function, I'm going to start, and let me see if I can move these over just a little bit. Wanted to make sure we have plenty of room. So our piecewise function might look like this. Goes down, then it goes straight over. We have a solid point. This is not working well. Give me a second to try and draw this one more time. It goes down and over, closed dot. Now I'm going to put an open dot, have it go slanty down, closed dot, another open dot, and then here we've got a curve. So I want to know, is this a function or is it not? So again, the idea is you can think about placing vertical lines. I'm using the laser pointer here to simulate some vertical lines. Everywhere the laser is pointed so far would pass the vertical line test. So then we have to ask ourselves, what about here where we've got the gap? Would this pass the vertical line test? And the idea is yes, it would, because notice that this was an open point and this one's a closed point. So this one says don't include this endpoint, and this one says include it. Square bracket, like interval notation, open bracket. So even though it seems like maybe when we draw that vertical line it's passing through 2 points, it's really only passing through one. Passes through the closed dot point. And we can draw vertical lines on this segment. We're okay there. Again, we don't have a problem right here. And anywhere else, assuming that this is not vertical, which is my intent, that would mean that this does in fact pass the vertical line test. So it is a function. If we made some changes though, if I had done something very similar, but instead used 2 closed dots above and below each other. Do you guys see here that now if I draw this vertical line in, it hits the graph at 2 points, so this one would be not a function. Looks almost exactly the same, but that's the difference between a closed point versus not a closed point. And then I wanted to do one more graph. Let's do something that looks like this. Hopefully you look at this graph right away and you say, it is not a function. You can pick almost any place on this graph and it'll pass through more than one point. On this particular line, it passed through 4 points. So again, this one is not a function. I would like to continue exploring if something is a function or not, but in this capacity, I would like to not look at some graphs. I'd like us to look at some ordered pairs and some tables, and I will probably actually have you guys remind me to do the birthday function in class. That one's kind of fun. So, function or not. Here's the first example. It is the set of ordered pairs 4, 5, 5, 5, and, whoops, I don't need to write and, 5, 7. So my question for you is this a function? It is a relation because we said any set of ordered pairs is a relation, but is it a function? Well, on the graphs we used the vertical line test, and what we were checking was to make sure that no first coordinate had more than one second coordinate. So here the idea is if we want to look at this, we need to look at the x values. What am I doing? Okay, so the idea is we're going to look at this first coordinate, and that first coordinate. Do any of the first coordinates repeat? Well, we can see that these two repeat. So this makes this first example not a function. Okay, hopefully that is making sense so far. So let's look at an example where we use a table. So on this table we're going to have time, and then we are going to have cost in dollars. So if we look at this table, it says between 0 and 30 minutes, the cost is $40, and between 31 to 60 minutes, the cost is $75. I want us to decide, is it a function or not? So, do you have any ideas? The idea with this one, and a lot of people get confused because they like to look at the y values, but do we have more than one 0 value for x or for the time that goes to two y values? If we had 0 time, it was $40. If we had 30 minutes, it's $40. If we had 30 minutes and it was $40 or $50, that would make it not a function. But in this case, because each x value, or each input, goes to exactly one output, this is a function. Alright, hopefully these are starting to make more sense, but I'd like for us to look at one more set of ordered pairs. So we are going to look at the set of ordered pairs 8, -1, 4, 3. Another ordered pair is -8, -1, and then the last ordered pair is 0, 101. And again, my question is the same as it was earlier. I want to know, is this a function? So in this particular example, again, we need to check all of these first coordinates. Do any of them repeat? And if they do repeat, do we get different y values? None of these x coordinates repeat themselves, which would make this a function. Okay, so now we've been able to look at some ordered pairs and a table to get an idea. Again, I'd like for you guys to remind me to do the birthday relation in class so we can decide if that's a function or not. And then the last thing that I want to do with functions is look at some equations. So as we look at some equations, we are going to decide, again, function or not. And the question we're really asking is why a function of x? Okay, if we're asking that question, what does that really mean? Well, if y is a function of x, then we've got y is equal to something only with x's. There's no way that we could get two y values, essentially. Okay, or really what we want to think, again, is there any value, here's another way to say it, is there any value of x where we can get two y values? If there is, then it's not a function of x. And so then we'd just say it's not a function. Okay, so we're going to start with the example where we have y is equal to the absolute value of x. Y is equal to the absolute value of x. So if you wanted, we could make an xy table, right? We could plug in -3, -2, -1, 0, 1, and 2. We could do other values if we wanted. If we plug in x equals 3, the absolute value, -3, the absolute value of -3 is 3. The absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. It's 0 units away from 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Do we have any of these x values where we'd be able to get more than one y value? And the idea is we don't, so that makes this a function. Okay, we'll look at some graphs here in a little bit, but we'll see in the next section that this actually satisfies the vertical line test as well. Okay, that was one example. What if we changed it and said x is equal to the absolute value of y? Doesn't seem like it's that different, but we want to know, is this a function? In a sense, is this a function of x? Okay, so let's think about picking some x values here. Maybe we wanted to think about -1, 0, 1, and 2. Okay, so the first thing we'd have to ask ourselves, is -1 ever equal to the absolute value of y? And the idea here is you guys know that this is not true, right? This is inconsistent because the absolute value always gives us a positive value. Is it possible to have 0 is equal to the absolute value of y? Well, sure. That would be true if y was 0. What if 1 is equal to the absolute value of y? Well, certainly y could be 1, but why could it also be -1? Because the absolute value of -1 is 1. So this right here, we don't even have to go any further, tells us that we have one input, we get two outputs, so it is not a function. All right, before we look at something else, I'd like us to think about one more example. And I'm actually going to give you guys a minute to write this down. I'd like for you to pause it and think about it for a couple minutes, and then you can hit play and see if you agree with me. Okay, so let me get us some room. All right, here we go. So the last one I'd like for you to think about is x cubed plus y squared equals 0? Is this a function of x? Is y a function of x? Okay, so to start this, you are going to think about, is there any x value you can plug in and get more than one y value? Go ahead and pause, ponder this a moment. Okay, hopefully you've pondered that for just a moment. So here's the idea. If we were to try and solve this equation for y, we would start by subtracting x cubed from each side. So we would have y squared is equal to negative x cubed. And to get y alone, we would take a square root. And don't forget, we'd take a positive and negative square root. So we'd get y is equal to plus or minus the square root of negative x cubed. Well, don't panic about this maybe being an I. What we care about to decide this is notice that we could get y, it's either a positive value or a negative value, which means this is not a function. Anytime we have equations, we can try to solve them for y. If we only would get one value, that'll mean y is a function of x. If we got more than one y value, like we saw in this specific example, because we got this plus or minus, that makes it not a function. Function. No s needed. Okay, that concludes trying to decide if something's a function. Please go ahead and look at the next video, which will cover domain range, function notation, and then we'll look at the difference quotient here.